Hi everyone. So in a previous video, I went over how we can use the law of sines to solve for a missing side length of a triangle when we're given two angles and a side length of the triangle. Now in this video, I'm going to show you how we can solve for a missing side or angle of a triangle when we're given two sides and a non-included angle. Suppose we want to figure out the measure of angle A in the triangle diagram that's on the screen. Now notice how we're given two side lengths, the 9-unit side length and the 4.9-unit side length. We're also given an angle that's not between these two sides, or the 48-degree angle. Recall that the law of sines can be used when we're given two sides and a non-included angle of a triangle. The law of sines tells us that in a triangle, the ratios of the sine of each angle to the side opposite that angle are all equal. So right here we see that the sine of angle A over the side opposite A, which is little a, is equal to the sine of angle B over the side opposite angle B, which is little b, which equals the sine of an angle C over the side opposite angle C, which is little c. Remember that we only need to set two of these ratios equal to each other depending upon the variable we're trying to solve for and which angle and opposite side pair we already have. We're trying to solve for the angle at A, so we're going to use the ratio involving A, which is this one right here, and because we have both angle B and the side opposite angle B, which is the 9 units, we're going to use the ratio that involves B as well. So we're going to set those two equal to each other. And now we can just fill in the variables with the information that we've been given. Since A is the angle that I want to solve for, I could just leave A blank in the formula. Side opposite of angle A is little a, which is 4.9, so I'm going to put that in the denominator. And then I'm going to set that ratio equal to the sine of angle B, and we know that angle B is 48 degrees, so I've filled in B with 48. And we're going to put that over the side opposite angle B, which is the 9 units, so that's little b. Now what we can do is some cross multiplication in order to solve for the angle at A. So we're going to multiply 9 times the sine of A, and then we're also going to multiply 4.9 times the sine of 48, and then we're going to set the results equal. Now after cross multiplying, so when we do 9 times the sine of angle A, we just get 9 sine A, which is what we have right here. And then when we do 4.9 times the sine of 48, we just get 4.9 sine 48. So then we just set those two results equal to each other. And now we want to get the sine of A by itself. So what we could do is divide by the constant being multiplied by the sine of A, which is just the 9. So in this step right here, I'm just dividing both sides of the equation by 9. And what that's going to do is that's going to leave us with the sine of A equals roughly 0.40. So at this point, you might be wondering, how do we actually figure out the measure of angle A if we know that the sine of A is equal to 0.40? Well, this is where we have to use the arc sine function or the inverse sine function. So that's that sine -1. And you can get that on your calculator if you're using a TI-84 graphing calculator by hitting second sine and then just putting the 0.40 in parentheses and then pressing enter. So when you do that, you should get that the measure of angle A is 23.6 degrees. Now, it's important to mention that there are two angles between 0 degrees and 180 degrees that have a sine of 0.40. 23.6 degrees is just one of these angles. In some cases of the law of sines, the measure of a missing angle can have two possible values. When this happens, we have what we call the ambiguous case of the law of sines. The word ambiguous means unclear, just for future reference. Now, whenever you have a case in which you're given two sides of a triangle and a non-included angle, just like we have in this problem, you always have to check to see if there are two possible measures for the angle that you're trying to find. Now you're probably wondering, how do we figure out if there are two different answers for the measure of angle A? Well, we just need to figure out the other angle for which the sine of that angle is 0.40. And doing that is actually really easy. All you have to do is find the supplement of the angle we found. So you know how we found the 23.6 degree angle? So find the supplement of that. In other words, subtract 23.6 from 180 and see what you get back. So when we do that, we should get back 156.4 degrees. So at this point, we want to check to see if 156.4 degrees is a valid measure for angle A. So to test whether this measure is possible, we just have to add it to the measure of the angle that we've been given, right? So remember how in the beginning we were given the 48 degree angle in the diagram? So because of that, we're going to add 156.4 to 48. Now when we add 156.4 to 48, we're going to get 204.4. Now, two angles of a triangle must always sum to a value that's less than 180 degrees. Otherwise, the triangle doesn't exist. So because when we add those two values, we get 204.4, this tells us that 156.4 degrees is not a valid measure for angle A. So the only possible measure for angle A is 23.6 degrees. So I know the print was really small just now, so I'm just going to recap everything that I just stated. So the ambiguous case of the law of sines occurs when we're given two sides and a non-included angle of a triangle. When given a case of two sides and a non-included angle of a triangle, apply the following steps. Step 1. Use the law of sines to find the measure of the missing angle. So remember that when we did that, we got that the angle at A is 23.6 degrees. Step 2, once you find the measure of the missing angle, subtract it from 180 to get the value of the other possible measure for that angle. So remember that we subtracted 23.6 from 180 to get the other possibility for angle A, which is 156.4 degrees. Step 3, add this result to the non-included angle you were given to begin with in the triangle diagram. So in other words, we're going to add the 156.4 we just found to the 48 degrees, which was the angle that we were provided at the beginning of the problem. If this result is less than 180, then there are two valid measures for the missing angle. This one and the one we found using the law of sines, meaning the 23.6 degrees. If the result is 180 or greater, this measure is invalid. So when we add 156.4 to 48, we get 204.4, which is clearly greater than 180. But two angles of a triangle must have measures that sum to less than 180 degrees for the triangle to exist. So because we get 204.4, this tells us that 156.4 degrees is not a valid measure for angle A. So the only possible measure for angle A is 23.6 degrees.